point, maybe something like this, right? And that 1 point that it crosses at is your one solution. Okay, so I would write above here, crosses at 1 point. Okay, so if it crosses at 1 point is one solution, what would no solution look like? Show me with your arms. Yeah, right? The parallel lines. If they never cross, it's going to be no solution. Makes sense? Right? Parallel lines don't cross. Okay, if we use the same kind of logic here, then what does many solutions look like? Yeah, beautiful. Two lines on top of each other. They cross at every point, right? They cross at every point. Two lines on top of each other. Okay. Two lines on top of each other. They cross at every point. Okay, so those are your different types of solutions with systems of equations. Remember, systems of equations are just two equations. Okay. So when you come down here, it says, without graphing, does each system have 0, 1, or infinitely many solutions? To start, we are going to rewrite each of them in slope-intercept form. So take a minute. Get these lines all in y equals mx plus b. Go ahead. All of them should be in y equals mx plus b. All right. Jose Velasquez, how did you get the first equation into slope-intercept form? Divide by 4. Good. So we have y equals 12x divided by 4 is 3x, and negative 8 divided by 4 is negative 2. Okay. Juan, how did you get y minus 5 equals 3x into slope-intercept form? Beautiful. So we have y equals 3x plus 5. What do you guys notice about these equations? They have the same slope. Okay, what does that mean? They're parallel. Same slope equals parallel equals what? What does that mean? No solution. Right? No solution. All right. Alexa, how did you get the top equation here in slope-intercept form? In number 2. Add 3x, good. Then what? Beautiful, divide by 6. Okay, so we have y equals 12 divided by 6 is 2, plus 3 divided by 6 is 1/2 x. We're always going to want to simplify, right? Alex E., what do I do for the second equation to get it into slope-intercept form here? What? I can't hear you. No. Try again. What? I can't hear you. No. We're going to get into y equals mx plus b. How do I get rid of the 2 next to y? Huh? Divide, yes. Okay, so we have y equals x over 2, that's 1/2 x, plus 4 divided by 2 is 2. What do you guys notice about these lines? Not really. Y-intercepts are the same, and so they're the same line. Yes? Do we agree? Okay. Same line, which means what? Huh? Many, good. They're on top of each other. They're 2 lines. They're the same thing. So that's many solutions. Number three. Aaliyah, how do we get rid of this 1/5 here next to the y to get it into slope-intercept form? What? Multiply, good, by what? Yep, 5 over 1, or just 5 is fine too. And what we do to one side, we got to do to the other, right? So we have y equals 5x, and 5 times negative 1/5 is just negative 1. It also cancels that out, right? Okay. David, how about this equation down here? X equals 11 minus y. How do I get this in a slope-intercept form? Sure. Okay, so we have y plus x equals 11. Then what? Yep. Okay, so we have y equals 11 minus x. What do we notice about these two? Are they the same? No. In no way whatsoever, right? So this is an example of just one solution. They're just going to cross at one point. Okay, questions. So today you're going to be graphing. When you're graphing, first up, my best advice to you, and you don't have to do this, but I would get both equations into slope-intercept form. Because even if you're not graphing them right away, if I get them into slope-intercept form, I can tell if it's no solution, many solutions, or one solution. So for example, if I get them both into slope-intercept form and I see number 1, and I don't have to graph, I'm going to say I'm not even going to graph that, right? There's no solution. Okay, it tells you a lot about them. Now, if you prefer to graph in standard form, you can do that as well. You just don't get as much information about them. Then you're going to graph each separately. Graph each line one at a time. And then you're going to see where they intersect. If they do, to find the solution. Give you guys a minute to get that down, and then you're also going to need Desmos. Okay. So I'm also going to show you how to do this with a table. Because you are not always going to be able to use a graphing calculator. Okay, but you can also just kind of do it differently here. Okay, I'm going to show you how to do it on the graphing calculator with a table. Okay, so you're going to click on add and you're going to click on table. Okay, now in our table is just going to be the two equations. So 5x minus 7 in one column and 5 minus x in the other. And we are just going to create this table, erase the x's, and completely copy down what we had. So erase little ones, just put x, 5x minus 7, and 5 minus x. Okay, and another way to do this, if you don't feel like graphing or you don't have a graphing calculator, or that you have a question like this in the ACT that you just have to identify it, we're going to plug in some numbers and see and look for where we think they intersect. So let me just start doing, I like to start negative, -2, -1, 0, 1, 2, 3. Okay. Now I'm just plugging in a bunch of numbers, and what's great about this is Desmos does it for me. Desmos does all the outputs for me. And then I take a step back and I look at my table and what am I looking for in my table? What am I looking for? Yeah, how do I know where they intersect looking at the table? Yeah, they have the same output, right? Where do we see that? 2, 3, good. We see that both of them have the point 2, 3. That means that's where they cross. So something I like to do, I really only use the tables when I'm checking my work, and we'll talk about that in another problem. Okay, but it's just kind of to confirm that that's where they cross. So I'm going to write down these inputs that I plugged in. I'm just copying this down from my table. I want my answer in there, so I'm going to copy these points. And I'm going to say, okay, cool, this is the solution. How do I know that? Because I get the same output for each input, right? Well, 5 minus 2. Okay. Once again, I got this 2, 3 because that's where my output's the same. My x value is my solution. I'm plugging it in real quick to check it. You don't have to do this. But 10 minus 7, is that equal to 5 minus 2? Yeah, they're both 3. Questions? Yeah. On the Desmos? Yes. So you're going to go to the Desmos. You're going to click on the add. And you're going to click table. And then the biggest thing is you got to erase the 1. And you got to put your equations up here. Or your expressions, I should say. Okay, so I erased the 1 here. I just made this x. And then I just plugged in numbers, and it calculates it for me. Good question. Other questions? Okay. So you guys are graphing these, right? Should be pretty simple there. When you get to this problem, it's the same thing we just did, except honestly, I would graph it first, find my solution, then plug it into Desmos, make sure that it's true. So when it says f1 of x, that's just saying, hey, this is 4x plus 3, and this is x. Now, some of my kids in my last class were like, well, Miss Cullen, it won't let me do this. Well, you can write +0, but guess what? It's because if you're putting 0 here, this is 0 too, right? Because it's just saying x is x. Okay, so check your answer using the table. Tell me the solution on that one. This one, people also get afraid of. Just because it is a word problem, we kind of got to write our equations, but it's not scary. All right, let's talk about it. Has anyone ever been horseback riding? Nobody? You have? Nice. It's fun, right? It's kind of scary. Yeah. That's fun. So you have two places, Horsey and Black Beauty. Okay, Horsey charges a $20 flat fee plus $10 per hour for horseback riding. Okay, so what is my M here? What's my slope? 10. 20 is a flat fee. That means that's my B. Oops. That's my B. And $10 per hour. Remember, slope is reoccurring. So my equation for this would be 10x plus 20. $10 per hour plus $20. So what this process is showing is us plugging in the amount of hours. Even if I go to Horsey and I don't ride for an hour, I ride for 0 hours, I just show up there to get inside is going to cost me 20 bucks. Just to get inside. That's what that means, right? If I ride for 1 hour, how much is that going to cost me? $30. If I ride for 2 hours, how much is that going to cost me? 40 bucks. This makes sense because every hour is $10 more, right? Okay, what about Black Beauty? They charge $15 per hour. Is there any flat fee? No. So this one's a little bit more per hour, but there's no flat fee. This is very, very common in businesses. Like very common. Okay? So a couple times you do this in life. I know it sounds like you don't do it in life now, but trust me, you will. When you're like looking for different companies for your house, one day when you own a house or you know your apartment, I'm doing it right now with all the wedding planning stuff, right? I'm looking at different companies to see if I can get the best cost, and they all have different things. So like this is real life stuff here. Gym memberships, that's a really good one. You know, this gym will charge this, and then this gym will charge this, and you're trying to figure out what's the better deal. Okay? There isn't a simple answer because a lot of these problems and systems, it depends on things, right? It depends, well, how many days a week are you going? How many months are you going? You know, how long do you plan to be there? Is there a sign-up fee? Is there not? So a lot of gyms will have sign-up fees. A lot of them won't. Some of them won't let you cancel until 30 days out. A lot of that stuff. Okay, so this case, it's just a slope. There's no flat fee, right? So if I go to Black Beauty and I just want to come in and look at the horses and I decide, I'm not going to ride. I don't have to pay any money. It's $0 because I'm only charged per hour that I ride. Okay. You guys are going to fill in this table and you're going to circle your answer. You're going to circle your answer. So go ahead and do that. And if you finish early, you can work on these. You're going to circle your answer. Go ahead. Try it out. Okay, where do they cost the same? At 4. How much do they cost at 4? $60, right? 10, oops. 10 times 4 is 40 plus 20 is 60. And here, 15 times number, it's gonna start costing me more, right? So 15 times 4 is 60. Now, what you'll notice is at first, if you don't wanna ride for a long time, Black Beauty is a better deal, right? It's cheaper all throughout until you reach this point, and this is what will happen with a lot of companies, until you reach this point where it doesn't matter if I want to ride for 4 hours, I can pick either one. And then after that, guess what happens? Black Beauty becomes more expensive. So people will say, why would they do that? Why would they charge, no flat fee? It's less money than this place. Not necessarily, right? Once you go longer, it's going to be more money than this place, okay? So this place may look more expensive at first, but it depends. Okay, so you guys are filling out that table. You guys are graphing these. Let's talk about these two real quick. It's pretty straightforward, right? So it says, is this a solution? Whenever you get a problem like this on the ACT in general, what should you do? Plug it in, right? They're saying, is it a solution? Okay, when in doubt on the ACT, you're taking every A, B, C, D, and you're plugging it in and saying, what works, right? So this is our X, this is our Y. In order for it to be a solution, it has to be true for both equations. So I'm going to try the first one. 8, remember, I'm just replacing my X with what they're telling me the solution is, and I'm seeing if it's true. Okay, same thing here. I have X, so that's negative 9 minus 3 times negative 1. I'm seeing, is that negative 12? Is this negative 81? What's 8 times negative 9? Negative 72 minus 9, right? Does that equal negative 81? What's negative 72 minus 9? Negative 81. Cool. Good there, right? Okay. What about the next one? What is negative 3 times negative 1? Positive 3, not negative 3, right? What's negative 9 plus 3? Does that equal negative 12? No. So guess what? No solution. Okay? No solution. They both have to be true. Questions? Okay, so you guys are finishing up 6, 3 and 4, 1, 1 and 2. Okay, the first page should be done. I will take volunteers. You're gonna have to volunteer for a problem tomorrow as well, so keep that in mind. When I'm not here. And you guys have 10 minutes to get your stamp. Andrew? This one? Okay. Yeah. Yeah, just fill it out.